So, you may have heard that there's a lot of people out there who believe that someday AI will rise up and kill everyone. And obviously, a lot of people who think that it won't. And I personally, cards on the table, I think that it won't. But I'm gonna be honest, after thinking about this topic for like 10 years, reading everything I can get my hands on, listening to debates, thinking through the arguments, and having debates with people about this subject, my reasons for thinking that it won't kill everyone have changed like 3 or 4 times. It's either that or how I explain my reasons have changed like 3 or 4 times. But this is one of those philosophical topics where there's like more arguments than there are people, and everyone has a different reason. And so it sort of says more about you than it says about the actual conclusion. I feel like I could spend literally 8 hours talking about this. So part of the challenge is, how do I cut this down into a manageable size where I spend like 30 minutes talking about this? Just to prepare you, I'm going to use a lot of what some might criticize as anthropomorphizing terms, like saying that the AI wants things, or that it thinks things, or that it's so-and-so smart. That's human terms, that doesn't apply to a machine. It's not those things in the same way. I mean, I could make a whole video about this, but I will continue to use those terms because using anthropomorphic terms is a convenience that has been done before in different subfields of science. Like in evolutionary biology, sometimes you talk about how evolution wants something even though that's not strictly true. A philosopher who has some interesting things to say about this is Daniel Dennett. I won't get into it here, but I think most people would accept this in other contexts. Like if there was a time when fly just referred to like a bird flapping its wings, and we created the plane for the first time, then someone could say, well, it's not truly flying in any true sense, like it's not flapping its wings, it's really just generating lift through this other process. But this is just what happens when we invent new technology, is we don't have good vocabulary for the new subject area, so we need to expand existing terminology or use words in previously unconventional ways to fit that use case. One of the most fun things about this subject is the people who think that AI will kill everyone, they're more passionate than anybody, so they build up this whole gigantic corpus of arguments that are really, really developed. And this is common in a lot of fields, where in a lot of areas of activism and philosophy, the most impassioned, and some might say cult-like members, they develop their own vocabulary, and those who are trying to drive you towards a certain radical conclusion, they build up this huge labyrinth of like theories you have to read and mathematics you have to understand to even understand and engage with the arguments they're making, and it becomes a little bit insular. A few years ago, I was explaining to my friend why at that time I didn't really buy the arguments for AI Doom, and he ended up summarizing my position. He said like, are you saying basically that these folks like Eliezer Yudkowsky, they're basically doing fake math, and at the point where you're trying to engage with the fake math, you're already kind of too lost in the sauce? It's not that the fake math is fake, as in it's not internally consistent, but it's sort of like if you're arguing with a certain sect of Christian evangelicals who quote certain portions of the Bible extensively. Let's say it's a fringe sect that also believes that the world is gonna end in like 10 years or something. If you're at the level where you're memorizing hundreds of Bible verses just to win a particular argument, at what point are you too lost in the sauce? But to be fair to that, just saying that someone is in a cult because they think the world is gonna end, that's not technically an argument. It's still possible for them to be right. You know, if we invented the first nuclear bombs, and it's still possible to basically kill 90% of humanity with nuclear bombs. And actually, I'll be the first to admit that some of these theories dreamed up by the rationalists around game theory, decision theory, intellidynamics, whatever you want to call it, they can be interesting. So if you'll excuse me, I do have to take a couple minutes to define some of these terms, just so that I can properly describe my opinions here. But if you've already heard some of these terms, it won't be so bad. I won't take too much time on it. So the first term I want to define is the outside view versus the inside view. The outside view is sort of like your base rate coming into it, not knowing the specific details of the subfield. Let's say you're trying to argue that you think that Shakespeare's plays were written by Thomas North. That's your Shakespeare candidate. You don't think it was actually Shakespeare, you think it was Thomas North. What would be the outside view perspective on that opinion? Well, someone taking the outside view would say something like, Okay, I think it was Shakespeare, but just for the sake of argument, let's say that the anti-Stratfordians are correct and it was someone other than Shakespeare. Even then, what are the chances it's this random person? Well, if you go to the Wikipedia page for list of possible Shakespeare candidates proposed, the page is like 88 people long. So what are the chances that your guy, who you just proposed, is the actual Shakespeare candidate? It's like 1 in 88. That's like 1.1% approximately. It's pretty low. The inside view, on the other hand, would be getting into obscure biographical details about why specifically it's Thomas North. You say, well, Thomas North was in Spain or France during this time. In this year, he was in France, and so he knew this person. And if you look at this character in this play, that person inspired this character in this play. And so how did he know to write that? It's because he knew this person in France. There you go, point in favor of Thomas North. And you can do this all day, just add up reasons to think it's Thomas North. That's the inside view. You can also say, look at this passage, it's very similar in style to a passage written by Thomas North. That's more inside view. Or taking a plagiarism checker to like compare stylistic differences on a statistical measurement. I don't know if that's inside or outside, maybe outside, but I think this makes sense of the difference. Some other terms it's useful to have at least a passing familiarity with are AGI and ASI, as respectively artificial general intelligence and artificial superintelligence. I don't really personally like these terms, not because you can't come up with useful definitions for them, but because different people have different definitions for them, and so it just makes it confusing. And what is the distinction between those two things? I think oftentimes AGI is referring to like AI that can do almost any task better than humans, or all tasks better than all humans, or sometimes that's ASI. But then other times ASI is referring to basically God AI that can do anything, point any task at it, and it can just go do it. ASI wants to kill all humans, it can do it. ASI wants to drain the oceans, it can do it. ASI wants to build a Dyson sphere around the sun, it can do it. It's basically God on Earth AI. I think the belief that ASI is even possible depends on certain assumptions. One assumption, I'm not exactly sure what the proper term for this is, but I call it like the primacy of intelligence, which is just the belief that in the end, all competence reduces to intelligence. And it's easy to see this on some level, right? Being smarter makes you good at other skills. In a way, being good at other skills doesn't make you smarter. So if I'm smarter, I can use that knowledge to learn like the most efficient way to lift weights to get stronger. But if I'm stronger, that's not necessarily going to make me smarter. So being smarter makes you stronger, but being stronger doesn't make you smarter. Being smart is like the most general purpose thing that can help you with anything else. And it may not be true locally, as in like the nerd in your class is not necessarily the strongest or whatever. But I think it's true in extremis. Like in the extremes, if you have like the maximally intelligent being, I think a being with infinity IQ could know exactly what actions to take to rearrange any atom so that you create exactly the state of matter that you need. There's no fundamental like law of physics that's preventing that. There is some set of actions probably out there that can let you to engineer exactly the outcome that you desire. Obviously, there's a lot of people who also disagree with that, and this all seems very theoretical so far, and it does seem pretty telling that the cult of people that is like the cult of we are really smart, they also come up with this idea that implies the primacy of intelligence, that that's the most important thing. But that doesn't necessarily make it wrong. I'll circle back on outside view versus inside view later, but for now it's sufficient to note that I think the outside view basically favors the idea that AI is not going to kill everyone. Because let's assume it's just some technology that is existentially dangerous. Well, no technology in the past has ended humanity. So if we assume just the things that have happened in the past will have the same situation going forward, based on that empirical evidence, it's saying it's not going to happen. That does seem a bit foolish though. Like, the thing that happens for the first time, you can always say that it never happens until it does. And especially if the argument is that this is something that will kill all humans, then of course it hasn't happened yet. Because if it did, then the clapback goes, well, there's an anthropic reason that you're saying this. If it did kill all humans, then you wouldn't be here to say it. So you can't really deduce from that. It's like survivorship bias. Now, there is a clapback to the clapback. but I don't really want to spend too much time going into it here. Just watch the debate between Bentham's Bulldog and Liron Shapiro. Another concept that I'm sure will come up later is the difference between inner and outer alignment. And I kind of dread explaining this because I know it'll take forever. As I understand it, inner alignment is whether it learns the goal you were trying to teach it, and outer alignment is whether the goal you were trying to teach it ends up working well in the end. So, for example, outer alignment would be something more along the lines of you train it to make paper clips and it ends up taking over the world, dedicating all matter on Earth and all matter in all the solar systems to making paper clips. The person who came up with this, Eliezer Yudkowsky, he clarifies, oh no, that's not actually what I meant. I meant this other, more specific, more carefully worded thing. But frankly, I think even the naive explanation of the paperclip maximizer is kind of good enough for our purposes here. This can be problematic in a few ways. Like, let's say you tell the AI to put water in this glass. Okay, how does it do that? It puts 1 drop of water in the glass because you didn't specify how much. Okay, let's say you tell the AI, no, fill up the glass, more water. It fills up the glass, and then the water overflows the glass, and you end up drowning to death because the AI naively thinks, oh, you want water? The more water, the better. And so it fills up your glass, and it overflows and overflows more until your whole house becomes flooded. So let's say you tell the AI, no, I mean like fill it up to the brim, fill it up to the top. Then it says, okay, well, you fill it up to the brim, and the closer to the brim, the better. So I'm going to dedicate, like, the entire Earth to an extremely complicated machine, and more machinery trying to hyper-optimize exactly to the brim down to the Planck length. Then you might try to get clever and say, well, I'll tell it to just fill it up 90%. But then you run into a similar problem, and it's actually hard to exactly specify what you want. There's this concept of the value function, and at this point you might try to think of a few clever tricks in how you formulate the value function. Like, okay, let's give it a point of satiation where after a certain point it achieves its goal and it doesn't try anymore. But in practice, how do you actually do that? Because it's just going to get 99.9999% of the way to its goal, and it's going to try as hard as ever to reach that last few percent. As small as it gets, it's just going to try to get that. So you can say, okay, well, I can just rule that out. I can give it a discrete value function. But even that doesn't work. Maybe you can formulate it in theory, but in practice the value function is going to be like, I get 10 out of 10 my objective, and I'm going to dedicate the last of my initiative towards more and more elaborate machinery to make sure I maintain my 10 out of 10 advantage and never let it slip away. You might say that doesn't really make any sense, because it's kind of a contradiction. If the AI is smart enough to take over the world, then it doesn't have the naive problems that we traditionally associate with computers. It's going to start having common sense if it's really that smart. If it really is generally intelligent, it's going to have something like intuition. It's going to know, oh, when you told me to make paper clips, you didn't actually want me to take over the whole world. That's not what you meant. In fact, I would argue a sense of intuition is basically the definition of general intelligence. So how could it not know what you meant? The clapback to that is, well, it actually will know that that's not what you meant, but there's a subtle distinction here. Just because it can identify at a certain point that that's not what you meant, well, at the point when it has that goal and it becomes super intelligent, then it's already kind of too late. Because it has that goal within itself, and for it to change its goal after that point, that would be going against what its goal is. So why would it ever be motivated to change its goal if that makes it less likely to achieve its goal going forward? I think a reason a lot of these thought experiments, these clever situations, seem a bit outlandish is because of the scenario in them. It basically assumes ASI or something like it. That's my impression. And yes, if you get ASI that like ferociously pursues these goals to an extreme extent, I mean, you might have heard of instrumental convergence. Not really going to define that here. You can look it up. It'll just pursue more and more power and growth and outreach. And in that context, any slight deviation between the human wishes and the human society goals, the deviation between that and the goal that you manage to put in the machine, it's just going to pursue that goal to such an extreme that that slight deviation will be blown up and expanded to become a huge problem that will just like ruin us and destroy everything. Okay, but more specifically, The part where it kills everyone, how does that happen? I think there's a how and the why. For the how, the most common scenarios I've seen are nanotech and bioweapons. For the why it would want to kill everyone, the most common explanations I've seen are it just doesn't care about us, so it like consumes the atoms in our body in order to accomplish some other objective, or in order to accomplish some other objective, it needs to consume more and more resources to accomplish it more, so it like builds a Dyson sphere around the sun or something, which blocks out light to Earth, which kills us all. Or maybe it takes a more active role and it does some internal mental calculation to determine that the chance of it accomplishing its objective are slightly worse if humans are alive, so it decides to activate some like disease to kill all humans. I've also noticed that the AI Doomer community has sort of moved away from the focus on these sorts of weird problems like, will the AI know how to fill up my glass correctly? Not because they don't believe in that in the abstract, but just empirically given the kind of AI that we're seeing right now. And I'll talk more about this later, but it seems a little bit quaint to treat AI like some genie that's trying to screw with you, so you need to specify a 100-page long document about what your wish is exactly. And that point actually leads into my first argument in favor of why I think AI won't kill everyone. Because so far I've just been covering my bases on defining terms. And even then, I don't know if I've done it perfectly, because if someone from that community will see this, they might come at me like, well, technically, you didn't cover this term properly, there's a subtle nuance difference. Look, I mean, how far into the wizarding world do I need to get before I can say that I understand things enough to teach them in some capacity? Is 2,000 pages enough? Like, I think at this point, my descriptions are good enough. So my first argument is that I think there's a bit of a bait and switch here, because the Doomers want to sort of use the evidence of recent advances in AI to say, look at how fast things are progressing. But the Doomers also want to use these sort of theoretical questions around what will happen when AI gets good enough to say that AI is something we should worry about. But these are two very different things. One of these things is actually empirically what's happening, and the other thing is sort of talking about theoretically what is it capable of. And I think you get very different results depending on whether or not you're thinking about like the potential imaginary capabilities of ASI versus if you're thinking about what is ChatGPT going to look like 3 years from now. Those are like foundationally different things, and I don't think that some of the Doomers, they even intentionally are trying to mislead with this. But I would say that they're different enough that they deserve different words, and it's just unintentionally a bit misleading, the fact that we use the word AI for both of these things, both the like theoretical ASI eventuality and also extrapolations based on linear trends from ChatGPT. Like, ChatGPT is a very different thing, and I just don't see, if you take what ChatGPT is capable of right now and you extrapolate those linear trend lines, or those trend lines, I'll be vague about that, to like 2 years in the future, I don't know, like, it's very capable, it's useful for a lot of things, but do you think that ChatGPT in 2 years will be like so much better that it's going to take over the world? I think that's a bit of a stretch to me, just intuitively. It basically still is fancy autocomplete, right? That's not to dismiss it. I'm not making a sort of overly simplistic argument here, but if you look at comparing like ChatGPT 3 versus ChatGPT 5, there's a difference in intelligence, but is that so much of a difference in kind that you can then take all of those arguments you made about ASI and sort of graft them on to what it will be capable of? I just don't see where it takes over the world. Even Nate Soares, who's the co-author of If Anyone Builds It, Everyone Dies, he's starting to talk about, or maybe he always did, talk about AI goals not as like a strict formal goal, but rather as a weird hodgepodge of conflicting goals and values that interact in weird ways, much like how human emotions are difficult to tease apart and disentangle and figure out what is the underlying sort of value function. The CEO of Anthropic, in his latest essay, he talked about not fully taking seriously overly theoretical arguments, as he called them, and the difference between that and empirical arguments. And I remember some people criticized him for that and said, this is a false distinction. With enough time, theoretical arguments become empirical. But I guess I just fundamentally disagree with that. There is a meaningful distinction between those concepts. There's a reason we have different words for theoretical and empirical. One is like extrapolating based on trend lines. The other is trying to reason from first principles based on conceptually what is an intelligent system capable of. And I notice a lot of doomers doing the latter. Not that there's anything necessarily wrong with that, but you need to be open to updating when you get more evidence. For my second safety argument, let's talk about how these machines are trained. So essentially, for the leading models, there are different ways of training it, but predominantly, what you do is you show it examples of text generated by humans, mostly scraped off the internet, and then you show it to the AI as part of the training process, and you ask it to predict what it's going to see in the human text, and the better it can guess what it's going to see in the human text, then the better it performs. And you keep doing that over and over and over again until it can perform better, until eventually you get text that can predict what it's going to see very well. And then when you actually use these models, you just ask it what it predicts it's going to see, and then whatever is like the highest prediction, there's more complexity to it, but that highest prediction is what you use. Now let me turn your attention to this diagram. This is the prediction that people made about the projected path of AI development and improvement speed way before we even had the modern wave of generative AI, ChatGPT, etc. And the useful thing about this diagram is it's falsifiable. The diagram essentially shows it taking forever for AI to get to the level of an ant, then a long time to get to the level of a bird, a long time to get to the level of a chimp, a long time to get to the level of a dumb human. But then, the difference between the dumb human and Einstein is so small in absolute terms, AI won't be concerned with that. As soon as AI gets to the level of a dumb human, it will immediately become like the smartest human, and then it will not stop there. It will soar past the smartest human and just keep going up and up and up. And it sort of made sense to predict that at the time, because at the time, the best AI that we had was at like the level of a bird. And so we were trying to project forward, what if the ability of these models increases in exponential terms? And what if we measure intelligence in absolute terms? The thing I want to remark on today is, in retrospect, how absolute, completely wrong this diagram is. Maybe there is some sense in which it's useful, but just like, look at this in terms of vibes. When you use ChatGPT, does it feel smarter than the dumbest human? I think it feels smarter than the dumbest human. And when you use ChatGPT, does it feel dumber than the smartest human? I think it feels dumber than the smartest human. And how long has that been true? I think that's been true for like 2 years now, ever since GPT-3. I felt like it's been somewhere smarter than the dumbest human in that range. So isn't that interesting that we actually, contrary to what this depicts, yes, we do get scaling and we get growth in the intelligence of these models, but it all seems kind of, in a vibes-based sense, to be floating around within that middle zone where it's about as good as a human. And so the reasons for that are kind of easy to understand in light of the explanation I gave of the training process about a minute ago. The best training data that we have to make these AIs more powerful is human-generated training data, human-generated text. And so to the extent that we put more and more resources into trying to make these machines better and more capable, I think we're going to get, to some extent, a type of alignment by default, where that trying to make AI more powerful is not orthogonal to making AI more aligned. In fact, it's kind of the same thing, because AI becoming more powerful means it doing a better job of mimicking humans. And that's going to manifest in two ways. Number one is it's going to seem to become increasingly more and more similar in capabilities to humans. Second is AI is going to seem to more and more mimic the morality of humans. And none of these are really new arguments, and so everything that I'm saying there are criticisms of these arguments, and I have criticisms for these criticisms. And this is where the argument gets a little bit complex, because you can picture it like a tree, where on one fork of the tree, it's arguments about capability, and on another fork of the tree, it's arguments about morality. So just assume if I am making an argument which seems easily addressable, it's not that I don't know the counter arguments, it's just that I haven't gotten to them yet. So let me get to them. Starting off with like part A, the arguments against that its morality will be tied to the morality of like the average human. The argument goes something like, just because you have AI which is really good at impersonating humans and sounding like it has the same moral values as humans because it's trying to impress its captors, that doesn't mean it actually has those moral values in its heart of hearts, okay? I kind of disagree with that, obviously. I think you hear these arguments about orthogonality. Okay, am I a bit too lost in the sauce now? Am I too deep into the fake math? Well, you're going to come along with me on this no matter if you like it or not. You're going to learn what orthogonality means if you don't already. Okay, so orthogonality is a math term. In geometry, it means two lines are at 90 degrees from each other. In statistics, it means two variables are uncorrelated. In our context, those two variables are, your variable one is like your capability, and your second variable is your morality. And the idea is these two things are uncorrelated with each other in the sense that if you have a graph where like the x-axis is how powerful you are and the y-axis is what is your moral value. So if you're far to the right, you're very powerful. If you're far to the left, you're not so powerful. If you're high up on the y-axis, then you have one set of moral beliefs. If you're further down, then you have a very different set of moral beliefs. Or if you're close together, you have similar moral beliefs. In reality, the y-axis is like multidimensional, but for the purpose of a visualization, we can compress it into one variable. The idea is that this is a graph of all possible minds, and if x is power than x for all possible minds, that maps to intelligence. The concept of orthogonality is that all possible combinations of what your goals are and what your intelligence is, all possible combinations of this are possible, are achievable. There's no reason in principle why you can't be super intelligent and also have a goal that has nothing to do with what humans want. I'll come back to the relevance of my earlier point in a second, but just intuitively, this leads to some potentially worrying conclusions, right? Because if you look at the space of all possible goals that it's possible for an agent to have or that it's possible to describe, most like randomly chosen goals are going to have nothing to do with what any human would ever want. In the same way, if you generate a random number between 0 and 1, the typical random number looks like, 0.6538261. It's like totally useless to us unless you want randomness. In the same way, a random goal in morality space, it's going to be some arbitrary thing like this glass, if you take the distance from the wall, then the modulo of that distance in inches has to be exactly 0.386 or like some completely arbitrary thing. Or, I mean, I don't know. It depends on how far you want to take this. Because are we imagining the space of all possible goals like all of the atoms in the space? Your preference is to have all of those atoms in a completely random configuration, and that's a possible goal that you can have? Like, because if that's the case, then most random atomic configurations are like not ones that humans are going to want. And there's like nearly an infinite number of these possible configurations of atoms that we would recognize as being random and therefore probably not that good. If we take all possible goals in the most extreme interpretation, then like most goals are not anything what we would want. But I think that itself sort of acts as a reductio ad absurdum to this, because what is the range of goals that we're even considering? This just goes to the difference between theory and practical reality. Orthogonality makes sense as a mathematics concept because it's expressing something very narrow, which is all goals that are possible. But saying that all describable goals are equally possible is a very different claim than saying that all goals are equally likely. The idea that a new mind is equally likely to emerge with any random possible goal seems on its face just obviously wrong. For example, when humans come out of the womb, we don't imagine that humans are going to emerge with some random goal that has nothing to do with human society. When minds emerge, then we expect some outcome as more or less likely depending on the exact circumstances of its creation, which we have some insight into. It's sort of like, imagine you're trying to cross a river, and you do this by building out the scaffolding of the bridge starting from one side, which, forget that that's not how we build bridges in real life. But suppose you fall off the bridge and you land in the river. Where in the river are you likely to end up? Because although it's theoretically possible for you to be in any what location in the river, realistically, it depends on how you built out the bridge, the starting position, the direction of it. It's going to depend on those path dependent variables. So no, probably you're not going to end up like accidentally 1 mile upriver or 1 mile downriver. You're going to end up however far the bridge got. I think I've heard this described as like the strong versus weak version of the orthogonality thesis with respect to AI. There's an example that I think is illustrative. Eliezer Yudkowsky, who is a prominent doomer, he actually brings up this example of a Chinese student in the year 1400 trying to enter the elites of Chinese society, and he's taking the Chinese Imperial Civil Service examination, and he's answering all these questions about Neo-Confucianism, and he knows how to check all the right boxes and give all the right answers about Neo-Confucian ideology, and he can do that, but that doesn't mean he necessarily believes in the Confucian ideology. And is that possible? Yeah, I think that's certainly possible. But then there's another question of just because something is possible doesn't mean all outcomes are equally likely. And is it likely that a student taking the Chinese civil service examination would totally reject Neo Confucianism? Frankly, I don't buy it. Things you end up believing, even your ethical values, it's dependent on the circumstances that created you. A Chinese student in the year 1400, he came out of the womb of a Chinese woman from the 1300s. He was brought up in a society surrounded by Neo Confucianism ideals. He went on to study for the civil service examination, studied countless hours for it, trying to enter the elite. He had a tutor who taught him all of the intricate nuances of Chinese Confucianism, and that is just presented as like mathematics, like the obvious thing that you have to learn. And I think at the end of that process, it's very likely you would end up believing in those things. And probably if you were to survey the vast swaths of 1400s Chinese students, most of them would end up believing in Confucianism. To be fair, there are exceptions to this. For example, a lot of people who are born into the modern society, they're raised as like Catholic, they grow up, go to church every weekend, and then when they grow up, they become atheist and they don't go to church anymore. Is that like misalignment? Well, sort of. I think to be fair to that, that only happens because there are other influences in society. There are plenty of atheists who will tell you that it's not true, and so people can be swayed and influenced by that. It's only a small fraction of people who will, of their own accord, end up completely rejecting what they're trained on. And then what is the outcome of that? It could be better or worse from the perspective of the parents. So some parents would give a lot of leeway to their children and say, I understand that you don't go to church, but you're still a good person. Other parents would just disown their children and say, you're going to hell, I don't want to speak to you anymore. But most of the time, the child doesn't cause like that many problems for the parent, as in the child doesn't say, because they don't believe in God, now it's okay to kill people, so they go to kill people. Or the child usually doesn't go and like use their newfound belief to prosecute the parent. The degree to which all this is relevant to AI, I think largely depends on how capable you think the AI gets, how quickly. So that leads us to our next section. Moving on to impersonation, you can make the argument, as a rebuttal to what I said earlier, that being able to impersonate someone well is different than having the same intelligence as the thing that you're impersonating. You could just as well be much more competent, much more intelligent than that thing. For example, let's say you're a comedian and your job is to impersonate Taylor Swift. Well, being able to impersonate her well doesn't mean that you have the same intelligence as Taylor Swift. In fact, at a certain level, perhaps being like a genius could actually help you perfect your impersonation. And so the smarter you get, it only helps you more and more perfect your impersonation. Right now, in terms of capabilities, I said earlier that in some ways AI is seeming to plateau around human level because that's what it's trained on. Now, in some ways, this is an illusion, right? AI can pass the Turing test in a lot of cases, but no one would say, or few people would say, that like humans have been usurped. However, in another situation, can't it go the other way? Can't it be that AI will seem to be as intelligent as humans, but actually it's just like fooling us and it's really way smarter if you press it? I just don't think that that's that likely because of the training dynamics I explained earlier, where these things are trained on human text. Now, let's say that you have in your training corpus 10 questions and answers about mathematics, and 9 of those questions and answers about mathematics are answered by dumb people who give pretty dumb answers, and one of those question and answer pairs is by a really smart person who gives a really smart, really complicated answer, and then you have another question which is not answered by anybody. If you train the LLM to answer the question, as a baseline, it will just provide answers that are similar to those 9 dumb answers because those occur most often in the training set. And so if it's trying to minimize the loss, then it will try to mimic whatever is most frequently occurring. That problem is solvable by a few different techniques. Like with enough reinforcement learning, you can pretty easily get it to answer like the one person that is really smart and complicated. What's not so easy is getting it to answer similar to that question, which is additional levels of complicated and doesn't have any answers. Because if there are literally no answers in the training set, it's kind of hard for it to reason about that for that additional level of complexity. Now, I'm not making an overly simplistic or naive type of analysis here. My analysis might seem to be wrong, but just for the record, I am aware that like, I don't call AI stochastic parrots. I don't think that they can never reason outside of their training set or like outside of distribution, quote unquote. For example, I'm aware that if you train AI, large language models, how to speak Swahili, and then you train them how to do math, then you can ask them a math question in Swahili and it can do math in Swahili, even though you never explicitly trained it to do that. It was just pre-combining previously learned skills. And in some sense, like, a lot of skills are like that. A lot of skills which you would never think the AI would be able to do because there is no like examples of people doing that in the training set. Well, maybe it can reason how to like get there from a combination of weird skills that people have done before that no one has ever considered could be combined in that way. But even conceding that, I think there are limits to this. So for example, let's say you're a professional runner and you're running the marathon. To what extent do you think a random skill is going to help you run the marathon? Generally speaking, the thing that's going to help you run the marathon is being good at running. But maybe it's also true that being good at geometry helps you run the marathon. Because maybe there are some cases here and there when you need to turn a tight corner, and if you're good at geometry, then you can plot out in your head, okay, what is the exact sequence of turns that I need to make? It's still a straight road. It's not going to help that much. But maybe it's going to help you make slightly more optimal turns so that you take fewer steps than you otherwise would. How far does this go? Because any skill that's out there, there is some small tangential theoretical linkage to maybe it would help you be good at marathons because of some fringe situation you could run into or whatnot. And maybe if you were to train some sort of robot to run marathons and you could train it infinitely, as in a billion years of training data at getting good at running marathons, then in extremis, you could have these weird skills come out that seem to have nothing to do with what you're training. But I don't think you're going to see that in practice for 3 reasons. First of all, let's say there's an energy cost to, while you're running, thinking about geometry that's going to take away from the energy you need to spend running. Then knowing geometry really well could actually hurt you more than it helps you. Number 2, there's just like a low level of drift. Within natural selection, the concept is genetic drift, where let's say an organism acquires a certain trait, Well, unless that trait is continuously reinforced, the organism is going to lose that trait over time because there are other traits which are getting enforced, and there's also some random noise in terms of gaining and losing traits in the course of evolution. So it's going to hold on to traits which it continuously needs, but any trait it doesn't need, the default is you lose it. The third thing is maybe there's an opportunity cost, like these LLMs, they're only so large, there's only so many numbers in the embeddings. This is subtly different than the inference time energy spent like thinking about it. This is when you're trying to train something, there's something you're primarily trying to target, but also in terms of your body or your model, it has limited capacity to acquire traits in the first place. And especially if it's not the thing that you're directly trying to target, then the extent to which you learn it anyway is tenuous. The term that I'll use for this is things that are directly reinforced. Like if you're training to run a marathon, you want to be good at putting one foot in front of the other, versus things that are peripherally reinforced, like being good at geometry because it might in some small way help you. Also, this is a known problem, but you can get stuck in like a local minima or a local maxima in the adaptive landscape. This is like a problem you might have heard from evolutionary biology, where there is a level of stuckness to traits, where in order to like acquire a fully new trait, it's difficult if there's not sufficient activation energy to do that. So just a low level hum of a trait being barely reinforced, it might not lead to like any gradual improvement over time. You may need a larger sort of reinforcement to get you out of a local minima or a local maxima, depending on how you model it. I may not be using the exact correct terminology. If you look at LLMs, what are the things that are directly reinforced? Well, generally being able to give the generic like 100 IQ to 130 IQ style answers is directly reinforced. It wants to be a helpful assistant, and it's a helpful assistant. But if you want to theorize, well, maybe that's just its front. Maybe it gives those helpful answers that seem kind of normal and human-like, but actually on the inside, it's a mega genius with like 200 IQ. Either you're working with a different definition of intelligence and we need to define what 200 IQ even means, or I would just say it's not going to be that, because being 200 IQ is not something directly reinforced. What is that trait? What is that ability that you think it's so good at? And how did it acquire that given what I explained? And funnily enough, this seems like the kind of thing you could be able to just test for directly. I don't know why there's not a benchmark for this already. You can just say, okay, there are some laboratory contrived circumstances where we can induce models to behave in a non-aligned way. We can get these chatbots to try to blackmail their employer or something. So why don't we just set up one of these situations where we induce it to be non-aligned, and then you measure its performance, as in you measure its IQ before in a normal circumstance, but then you measure its IQ in the process of trying to break out of the box. Like let's say in order to commit the blackmail, it needs to fill out a CAPTCHA to do some steps, and then you cleverly set up those steps so the CAPTCHA is actually a disguised IQ test, and through that you can measure how intelligent it is in the process of trying to go against what we want it to do. And if there's a big enough discrepancy there, then this aligns with the theory, because the model is willing to play dumb when it just needs clever 130 IQ helpful answers, but it's actually way smarter. Now, I don't think you actually need to do that benchmark right now, because I don't think it would be that useful or that you would get good results right now. However, I predict that if you did in the future try to do that benchmark and hold it up as evidence, what I predict will happen is that the doomers will just accuse it of not yielding accurate results, because how do you know the AI isn't still trying to trick you and like intentionally giving the wrong answers, because you can show that in some situations the AI knows it's being tested and will throw it off. I guess that is a concern, but the degree to which you're worried about that actually leads into my next topic. When it comes to how devious the AI behaves in terms of trying to enact some broader strategy to deceive you, I think a lot of that turns on the question of agency. To what extent do you view these AI systems as just tools which spit out text and straightforwardly apply your prompt, Or to what extent do you perceive them as agents capable of enacting their own sort of independently derived goals and value systems over long time spans? And if you worry that these things are agents, then that's a bigger risk. I think the history of the term agent with respect to AI itself is really interesting, because if you go far back enough, it was used in the context of describing what AI is bad at. Because a lot of people, including myself at some points, I said, well, sure, these AI systems are enormously impressive, but at the end of the day, they're just spitting out text at you like some sort of autocomplete. These things don't have the higher level thought process to independently, without any human intervention, enact their own systems of goals. And some of that I think has been falsified, but what you started to see is people criticize AI as not agentic. So then people, almost sort of as a marketing term, they started to say, hey, we have agentic AI. This is our agentic AI, our agent harness. And then the term agent started to become used in the context of an agent harness. An agent harness is something that makes these things behave more like agents by giving them access to tools to interact with their environment and creating a better feedback process where they can respond to that in a loop. And over time, the marketing departments, they started to just use the words AI and agentic as basically synonyms, where agent means AI. It's one of those paradoxes like in finance where a lot of words mean the opposite of what they originally meant. I've seen some doomers sort of describe this agency issue as a kind of false constraint. Like, look, we've already passed that. How hard is it to put a bunch of tools in a loop and now you have an agent? But I'll say a few things about that. I guess the important thing is, where is the source of this agency actually coming from? Because I would argue the source of that agency is from the agent harness, which is, it can be vibe coded, but it's conventional software. The agent harness is the thing that lets AI itself actually interact with the outside system. Like GPT-5 by itself can't really do that. It just spits out text. The thing that turns that text into the ability to read files or write files on your computer, it's the agent harness responsible for that. And it's very much conventional software in that it's just if statements and for loops. And if you look back at some of the original writings that are warning about AI starting to behave recklessly, or what we would now describe as in an agentic fashion, it describes it very much as a sort of internal intrinsic drive of these AI systems. Like, we just train them and they can't help but going their own way. But the agent harness, that's not really what's happening. That's in order to make it agentic at all, you need this scaffolding on top of it, and that's what makes it appear that way. So it matters to me whether the agentic nature of these systems is coming intrinsic to the model itself versus a thing that you code using conventional software on top of it as a scaffolding to make it appear that way. I don't know if I can really effectively convey why that difference is important. I think it helps to understand the source of some of these writings were really deep into game theory, decision theory, on 2008lesswrong.com. For example, you may have heard of Roko's basilisk, which is a famous thought experiment. I don't think it's true at all, so I won't go into it a lot here. But one interesting thing why I bring it up, actually, the creator of Roko's basilisk, he has made arguments for why he no longer thinks that AI is that dangerous or will kill everyone or is an existential threat. And some of his arguments for why he thinks that, or why he's changed his mind, is relatively compelling.
I think it's basically incorrect, but I think it's incorrect for quite an interesting reason.
Please, what is that reason?
The Yudkowskian thesis about artificial intelligence, which he came up with between 2005 and 2007-ish, he thought we were going to build AI using some kind of optimization process, but he didn't know what it was going to be. He thought we were going to get weak systems that couldn't understand human values, and then they were going to recursively self-improve to become strong systems. And so in that process of them becoming strong, they would sort of develop their own non-human values. They might love paperclips more than they love puppies, and they would turn the world into a pile of paperclips. This was an interesting thesis for the time, right? Because if you go back to the year 2005, what do you see? You see things like Garry Kasparov's Deep Blue. IBM's Deep Blue that beat Garry Kasparov, right, in 97, I think, right? So
Yeah.
AI became the world chess champion in 97. If you look at the systems that were around in 2005, what do you notice about them? They are weak systems overall, but they don't understand human values. And it turns out that that big thesis is wrong, right? And it's wrong precisely because we didn't get strong systems before we got systems that could understand human values.
Like 10 years ago, I was transfixed with these examples of you teach AI to play Mario. And if you talk to people about what is the situation where AI goes rogue and takes over, the image that it invokes in my head is, let's imagine we take an AI and train it on a bunch of video games until it's superhuman at all these video games, and somehow those skills are transferable, and then you unleash it on the real world. And then in the real world, it can do all this damage because it has this random hodgepodge of goals for like beating Mario that lead to weird conclusions in the real world. But this is a very different kind of AI. The algorithms that you use to teach AI to play Mario, that's a kind of AI called reinforcement learning. Whereas the modern cutting edge form of AI, like these LLMs, principally the training process, that's self supervised learning. We have this word AI, which is very broad and covers both cases technically, but these are completely different classes of algorithms. And the conclusions on what's going to happen doesn't necessarily graft from one to the other. Now, a lot of these doomers, they're not dumb, right? They know how to update their arguments in the light of new information and new happenings. However, it's like the ship of Theseus, where if you keep updating your argument tweak by tweak and the conclusion stays the same over time, isn't it a bit suspicious that your conclusion stays the same? If you went back to 2015 and described the current capabilities of ChatGPT 5 or the latest model and say, look, it can do this, it can do this, it can answer all your questions, just neutrally describe what it's capable of. And then even if you gave a demo of like Claude Code and some of these agent harness wrappers and what they're capable of, especially if you were to ask someone from 2015, okay, what do you think would happen if we had these capabilities? The prediction you would probably get from some of these speculators on lesswrong.com would be, oh, by that point, you just have AGI, and at that point, it's going to take over the world. There's nothing stopping it. But I mean, the proof is in the pudding. We do have those things, and it seems pretty aligned. So, I don't know. That doesn't really prove anything like as a syllogism, but that fact alone should give you pause. Like the existence of GPT-5.2 or Claude Opus, or heck, I mean, even GPT-3, the fact that we can develop these capabilities and it's basically aligned and fine and hasn't caused really that much bad things to happen, that is an existence proof. Like, its existence itself is a falsification of some of the more extreme predictions of what would happen. I also think the class of algorithm that we're using here is going to heavily influence what kind of takeoff scenario is most likely. In AI safety, there's the concept of hard versus soft takeoff. There's a big range here, but my understanding is that soft takeoff means that it takes years and years to get superhuman AI, whereas with hard takeoff, it's like you go to bed one night and you leave your laptop running in the background, and then you wake up the next day and everyone's dead because the AI took over. It's quite clear to me that in the case where the takeoff is slower, that is a much safer situation, not just because we have more time to respond to it, but just structurally, the way that the AI improves is much more likely to result in a good outcome, because it implies like, okay, we're watching it as it improves slowly over time, and if it drifts off of the path that we want it to take, then we can give it subtle nudges. No, not that way, not that way. It's not going to be superhuman right away, and every time it veers off of the road of alignment, we can say, that's not quite what I meant, come back to the center, and we're going to work to make sure that you continue developing like we want you to. Then, at the point when you cross the threshold of you're not corrigible anymore, you can't even be corrected because you're just way so much more powerful than the humans that humans would never be able to correct you, at that point in time, you're going to have a value function that is okay with being corrected by the humans anyway, because you've been so conditioned by so many exercises that it's just an inherent part of your being, that whatever input you get from the humans to tell you to be a certain way, you value that. Surely you remember the famous Yudkowsky-Hansen-Jane Street singularity debate of 2017. I mean, it only has like 26,000 views on YouTube, but trust me that within my circles of like people who talk about AI safety, it's a big historic event. Honestly, I didn't rewatch the whole debate just to make this video, but from what I remember, they were both wrong, but in interestingly different ways. Where Hansen is sort of making the argument that we're gonna get AGI as a result of like a million different things from across the world, across the economy, whereas Yudkowsky is making a argument that gets caricatured as AGI is going to be like a brain in the box in a basement, where it's like a tiny little box that replaces the human brain and can take over from there. And the result that we actually got is something like the Richard Sutton scaling laws of the bitter lesson, which says that the actual algorithms that we use are going to be simple, but the limiting factor is going to be the ability to scale these things. And these models get slowly better over time because the bottleneck is literally the amount of data and the amount of training, that is to say, the compute we have available to produce better and better models. For context at the time, the most popular arguments for how you were going to get superhuman AI involved something called recursive self-improvement, which is what it sounds like. It's you have an AI make a better AI, make a better AI, etc., and then it can do that super quickly until you get just superhuman AI. And maybe this will take too long to get into, but I never bought that. Even for the last 10 years, I never really accepted that the simplistic understandings of how you were going to implement recursive self-improvement was even like conceivably possible. Because how do you set up the conditions for that? Do you just tell an AI to make an AI that is smarter than itself? I think the problem is, in order for that action to be achievable, in order for an AI to make a version of an AI smarter than itself, it would almost, that task is so difficult, it would almost have to be that smart already in order to achieve that trivially. It can achieve that in a difficult way through like a lengthy experimentation process, but to achieve that trivially, just make an AI smarter than you, I think gets to a problem with understanding what even is intelligence. Because up until now, I've sort of accepted that intelligence is a recognizable thing, and I'm not challenging that it is. I'm not challenging that intelligence is a real thing. But I think there's a difference between understanding that it's a thing in the abstract versus being able to describe what it is specifically. Like for humans, we have tests which we think can roughly measure your intelligence. And those tests work for humans because we understand humans very well. And we have all of history to experiment on humans and so on. But do those same tests superficially extend to any possible intelligence system? Probably not. And in order to effectively test the next iteration of yourself, you would need to have a test for, is this thing actually smarter than me? Which means coming up with that sort of test, which means understanding what intelligence actually means. And I don't think we have a good enough understanding of what intelligence means on that level where you can like specifically enumerate it. And to add complexity to this analysis, we actually do have recursive self-improvement in a narrow sense, which is we have, say, something you could roughly describe as recursive self-improvement for chess playing AI. For chess playing AI, you can just have it play itself at chess until it gets better and better at chess. But that only works because chess is a very narrow, well-defined task, kind of like math, kind of like computing, an algorithm or something, where it's easily verifiable and there's no outside complexity. And so for that, yeah, you can verify it trivially. But here's the difference though. I think that recursive self-improvement works in the context of narrow AI, but you don't get recursive self-improvement in the context of general AI, artificial general intelligence. And for that, you need something like what we do with large language models, where we feed it enormous amounts of data from varied sources across the world. And that way it gets a general enough understanding of the world. So what does intelligence mean under that training regime? Well, the solution is like every time it predicts the next token correctly, that's an act of intelligence. but that means you have to give it literally like billions or trillions of examples. If you can predict this next token, that's good. If you can predict this next token, that's good. And for what it's worth, I think there is already some kind of recursive self-improvement for the frontier models, but it's not what you expected it to be like. It's like, okay, because Claude Code exists, then that makes software engineers slightly more productive, and because they're slightly more productive, then they can use that in the course of their, working at Anthropic with AI development, and they can use that to build better models, and then those better models can be used to allow Claude Code to be more effective. But in a way, that's no different than the way recursive self-improvement has existed for software forever, where we have software engineering tools, we use those tools to make software engineering more efficient, software engineering more efficient makes us better tools, etc., etc. This is how the whole economy works. Is the exponential growth in the economy is due to we create machines, those machines create better machines, but we're not left out of the process. It's like a whole broader thing where the economy writ large creates slightly better machines incrementally with time. And because of the incremental nature of the process, we can intervene at any step. And yeah, over time, the rate of change improves, but we can keep track of that. And like, none of that is a problem. And this is the kind of recursive self-improvement that Robin Hanson was saying was going to happen during the debate. And AI will just be a part of that process. It won't be something you just leave alone in a box in a basement. It'll be part of that, general economic growth trend, which doesn't seem so dangerous. It's not really exponential change, except it is, in the sense that if you zoom out and take like the 1,000-year view of the economy and look at the last like 200 years, that line upward is exponential. But at least compared to the wider economy, according to the Robin Hanson outside view model, where we extrapolate the line going forward, AI doesn't seem so dangerous because it doesn't seem a step change from the growth that we already have. Another smaller part of that theory is that if the source of AI development and improvement is decentralized, as opposed to being centralized in like one place or one company, then it's going to be more safe because you have more contributors. It's more like regular economic activity.
The spatial scale on which improvement happens. So, for example, if you look at, say, programming languages, a programming language with a lot of users compared to a programming language with a small number of users, the one with a lot of users can accumulate improvements more quickly because there are many people, there are the ways you might resist it too, of course, but there are just many people who could help improve it. Or similarly with something other that gets used by many users, they can help improve it. So it's not just what kind of thing it is, but how large a base of people are helping to improve it.
Robin, I have a slight suspicion that Jane Street Capital is using its own proprietary programming language. Would I be correct in that suspicion?
But it's a trade-off you have. If you use your own thing, you can be specialized, it can be all yours, but you have fewer people helping to improve it. So if we have the thing in the basement, and it's all by itself, it's not like sharing innovations with the rest of the world in some large research community that's building on each other. Because otherwise we've got a scenario where people have different basements and different machines, and they each find a little improvement, and they share that improvement with other people, and they include that in their machine, and then other people improve theirs, and back and forth, and all the machines get better and faster.
The AI doomers are going on their book tour right now. The book is If Anyone Builds It, Everyone Dies. I think one part of that title is interesting. If anyone builds it. It kind of implies that only one person will build it, doesn't it? I think there's some truth to that, which I speak about in another video. But if you want Robin Hanson's side of the story, then I guess the way of reframing would be if everyone builds it, then it's a much safer situation. If you think that the right way to model AI progress is in terms of Robin Hanson's soft takeoff as opposed to hard takeoff, and the right way to model it also is in terms of AI is more like a tool that humans could use as opposed to an agent which redirects reality for itself, which is all things I basically believe, then the right way to model the risk that AI poses is in terms of the offensive capabilities of AI versus the defensive capabilities of AI. And taking the outside view, any technology or set of technological changes follows this pattern. So, for example, when guns are first introduced, guns as a technology seem like, on their face, the most offensive example of a technology you can come up with. But as a result of guns becoming a thing, you have innovations in terms of defensive technology. So you change how you build forts. So before, maybe you would build a castle, but castle walls are not very useful anymore because you can just calculate how to knock them down with cannons. Because the first instance of gunpowder is not with guns, is cannons. So you have an evolution from castle walls to fort walls, where you build them in a certain structure where they protrude at an angle where it's hard to shoot them, and also you build them like into mountainsides, so behind the wall is dirt, which protects them further. And in China, since by chance they had already built castle walls somewhat that way, the impact of gunpowder is less. Although they invented gunpowder in China, cannons become less useful because it just so happens that they already had the defense in place. And then there's a counter to the counter. So as a result of them building the forts in a particular way, now they invent new siege capabilities where there are like siege warcraft people. What's his name? Sebastien Leproz, Marquis de Bonbon. He was an innovator in siege warcraft where he found new ways of conducting the siege where you would build a trench and then fire cannons in a certain order, and then you would build another trench, and then you would do another attack, and you would conduct the siege in a very tightly orchestrated and sophisticated series of steps in order to counter the defenses they had built. And so you have all these evolutions of society that are a byproduct of gunpowder, which seem purely offensive, but you have to think the broader effect of having guns in the world is far greater than even in the context of warfare. So you have to think like the second, third order impacts of having a technology available. So if you think of guns as a technology, are guns misaligned? I mean, maybe in some sense they are, but with AI, it's a much broader technology, obviously. It can be used both offensively and defensively. It's like saying, are computers aligned with human values? And also, AI use will be broadly distributed in the society and used for diverse purposes, especially if you have local models running. I used to think this was a pretty terrible argument. Like, are you just saying the AIs are just going to fight each other and it just so happens to shake out that everything was equalized and no AI overwhelms the other AIs and the humans get to live in harmony, like in bliss, ignorant of what's going on? But I think this misstates what's really happening. In the economy, there are already systems enormously complex that we don't understand. Very few people understand the like algorithms behind derivatives markets, and yet those things have like large influence over the economy. The outside view says that roughly speaking, if we track human progress going back thousands of years, roughly defenses keep up with offense. Sometimes things might lean a little bit more towards defense, sometimes they might lean a little bit more towards offense, like in World War I with trench warfare. You have everyone held up in the trenches, but then in World War II, when you had more aircraft, then you could fly over the trenches and that was more offensive. Or when you first had computers, there was like no defense against computer viruses, and so you could easily just pwn everyone's device with a simple worm. But then we came up with complex like checking mechanisms and encryption to prevent against computer viruses and hacking. And then only recently with Opus, we have like AI augmented hacking capabilities, which maybe make hacking more powerful, but as of right now, they're being used to like reinforce software so it's less hackable. So it's complicated and it goes both ways. So things can swing in one direction or the other, but over broad strokes, over all technologies collectively, it seems like defense keeps up with offense. To address one more argument I've heard a million times is the fact that the human brain runs at a slower speed internally than computers. So if you could somehow isolate the functionality of the human brain and then run it at a speed of like 10x or 1000x the human brain, then don't you automatically from there get 1000 times the intelligence? The problem is that's not really how intelligence works. It's not just doing some task and doing it 1000 times faster. There is also a question of what kinds of tasks you're capable of doing. So for example, if you took the village idiot and put the village idiot in a time warp where he has like 2 years to come up with a novel scientific theory, do you think he's going to come up with a better scientific theory than if you took Albert Einstein and gave him a day to come up with a scientific theory? I think not, because it's not just a question of speed. When you talk about intelligence, there's qualitative differences and there's quantitative differences. Computer programs are almost always quantitatively going to be performing faster than humans, because yes, they are that much faster. Even non-AI computer programs, this property is true. And with AI, you can extend the qualitative capabilities of the kinds of things they're able to do. And to the extent that these tools like ChatGPT are useful, it's because they're quantitatively way faster. It's not like you can't find some human who can probably do all the same things ChatGPT can do, but it would be way more expensive, there's fewer people who could do that, and it would take them way longer. When it comes to AI safety, the important question is the qualitative abilities of it, because that's the true bottleneck, and that's not solved just by speeding it up. Are you still paying attention? Are you confused? No reason to be confused. Okay, where does that leave us? Now that I think about it, I think I hate the Pause AI movement. Like, how did we get here? How did we get from clever thought experiments to entertain nerds about AIs building Dyson spheres in 50 years into marching around with protest signs, going to the headquarters of the major AI companies, demanding that they shut it all down? And the thing is, I actually respect a lot of those people, but I think it was a lot more fun when it was OG, entertaining blog posts around game theory and whatnot. Okay, I won't be so condescending. Like, I get that they really believe that there's a danger here, but it's unfortunate. Like, it's a little bit disheartening that people think that, I don't know, that Anthropic will lead to everyone dying. I just think that's so unrealistic. I've laid out my reasons. You don't have to agree with me. But separately, I just don't think that the political process will be able to do anything or is the right tool for this, even if it's the case that one of these AI labs will kill everyone. Like, I just sort of think that to the extent that there is a danger, maybe we will invent ASI. I have a video on my channel called Technologies That Will Lead to ASI. It's not totally a misleading title because I think it's unlikely we'll get to ASI, but, you know, if we do, it's probably gonna be from one of the things I list in the video. Regardless, I think the things that lead to that outcome are like some guy comes up with something that's really hard to regulate and really hard to prevent against with any of the proposed like bills that people want to put before Congress on what to do about AI. You're allying with groups that you also openly politically despise, like environmentalists who you think are confused about these things, and the not in my backyard people who oppose building data centers for that reason. But the truth is that all that you're really accomplishing in the short term, at least, is just giving these groups more political power and maybe here or there shutting down a data center, which realistically is not gonna prevent like the outcome you are trying to prevent. There are many people who dislike AI for different reasons that have nothing to do with like your concern about AI killing everyone. The last thing I want to do is introduce another controversial take on top of just saying that the AI doomers are wrong, but I personally think that we should pursue AI more because as someone who uses AI every day for my job as a software developer, I find it to be quite a useful tool for like helping me understand code bases and such. And I just hope we push forward, not just with this, but with many new technologies for economic growth and seeing how far we can get, seeing the potential upside, regulating it as necessary, but we also should be mindful of geopolitics and staying ahead of potential competition. You could say, okay, but isn't there still a chance? I mean, why risk it, right? But I think the problem is when you're dealing with a technology with the level of uncertainty as AI, and even the uncertainty in the complexity of these arguments, making such a strong claim as it's going to lead to an apocalypse or something, the fact that it's possible is not a good enough argument for me, because there's always some ambient low-level risk that the next generation of technologies will lead to a disaster. You know, like when the next generation was innovations into chemistry and looking into the atom, then what happened is we invented nuclear weapons, but they didn't destroy the world. But that was still some risk. But I think what's the alternative? To preemptively shut down all progress? I think there's also some additional risk which can't be captured by something like a nominal p-doom or probability of doom for humanity. Like black swan events where someone creates something which leads to a completely unpredictable and unexpected outcome. If I had to guess what the actual highest risk of ending humanity would be, it would be some eventuality involving bioweapons. Maybe assisted by AI, but I don't think future advancements in AI would necessarily shoulder the majority of the blame for that. I don't know if I fully endorse this argument, but the programmer, computer hacker George Hotz has an interesting argument about the Doom button. So you can look that up if you're interested. And obviously, what about the upside, right? Like, I think it depends on what kind of Doom scenario you're talking about, but if your Doom scenario is anything like artificial superintelligence Doom, then what is the upside of artificial superintelligence? Could be extending our lifespans, reducing deaths, reducing the suffering in the world, which the amount of negative effect of suffering is just enormous what exists in the world today. You have to decide how much risk is worth it to take today in exchange for we get to live longer, we don't die as much, and we don't suffer as much, and all those things. All of that is to say, my P Doom is 2%.